Welcome to this session. This session will give the first example on how to resolve forces acting on an object. And so we have a box of mass 8 kilograms lying on a smooth horizontal floor. A force of 10 Newton is applied at an angle of 30 degrees, causing the box to accelerate horizontally along the floor. So there are two questions. The first part is to work out the acceleration of the box. And then the second part is to work out the normal reaction between the box and the floor. So if you have such a problem, it is always good to sketch so that you can be able to indicate the forces acting on this object for solution. So if you assume that this is the book, then you have been told that the book, there's a force of 10 newtons applied at an angle of 30 degrees, causing the box to accelerate horizontally. So we can either draw that angle at this point at the top, or we can draw it here. So this is a force of 10 newtons. And then this angle is 30 degrees. So this is the horizontal. And then the mass of this box is given by 8 kilograms. So let's draw a force diagram, which is simply a diagram showing all the forces acting on the particle. So we'll have, so this is the diagram. So force diagram. So we draw this horizontal, and then let's draw our forces here. So we have the weight of the book, and then we have the normal reaction, which is perpendicular to the surface, or actually directly opposite to the weight. And then if we translate this force here, then we have this 10 newtons, and this angle here is 30 degrees. So this is our force diagram. So the thing will be to resolve these forces. So drawing a right angle triangle here, then this is the vertical, so this will be 10 sine of 30 degrees. This horizontal will be 10 cosine of 30 degrees. So by definition, net force is usually given by mass times acceleration. And so because this box is moving horizontally, then you say the net force in the x direction is given by mass times acceleration in the x direction. And then the force acting in the horizontal direction from this diagram is 10 cosine of 30 degrees. That should give us the mass of the box is 8, then times the acceleration in the x direction. So that tells us that acceleration will be given by a 10 cosine of 30 degrees divided by 8, which will be 1 point, or simply 5.3 divided by 8 meters per square second. So that will be the value of the acceleration. Part B is to calculate the normal reaction between the box and the floor. Now, resolving vertical forces, net force in the vertical direction is the same as mass times acceleration in the vertical direction. This by Newton's second law of motion. Now going to a diagram, vertical components, we have normal reaction, we have this force, and then we have this weight. So we'll have total forces acting vertically, we have R plus weight, which is minus. So taking these forces acting upwards to be positive, then weight is acting downwards to be negative. So it'll be the normal reaction plus the weight. So R weight is acting in the opposite direction, so negative, and then plus this component is 10 sine theta. Should give us mass times acceleration now. Because this box is moving horizontally, then vertical acceleration is 0. So it will be m times 0. So that means that R minus mg plus 10 sine of theta is 0. And then R will be the same as mg minus 10 sine theta. And when you work out this, you have R equals to mass is 8, G is 9.8 minus 10 times sine of the angle is 30 degrees. So this will give us 8 by 9.8 minus 10 sine of 30 degrees. That will give us 73.4 newtons are the size of the normal reaction force. So that is what we get for that given problem. Thank you.